Hello, dear learners. You are welcome to another maths episode class on JLDI Academy. In our last maths class, we discussed the concept of coordinate geometry, where we looked into how to determine the gradient of a straight line. How to determine the gradient of a straight line. So in today's class, we are going to be looking at the equation of straight line. So basically, the equation of a straight line expresses the relationship between the x and y coordinates, between the x horizontal and the vertical, which is y coordinates. So there are four different forms of equation of a straight line. That is, there are four ways to obtain equations of a straight line. So the number one way is the slope-intercept form. Number two, we have the point-slope form. Number three, we have the two-point form. Number four, we have the general form. So by the end of today's tutorial, you will be able to determine the equation of a straight line given any of these properties. And you'll be able to determine the gradient from any given equation of a straight line. So let's move into action. Recall, in our last class, we discussed how to find the gradient of a line. Maybe we should do it this way. As a way of verifying if you have been following us keenly, let me quickly give you a quiz based on what we learned last class, where we discussed the gradient of a line. Remember, in the last class, we concluded that the gradient of a line, which is denoted by M, is gotten by saying y2 minus y1 divided by x2 minus x1, where y2 and y1 are the coordinates given. Take, for example, for point A, where we have x1, y1, and we have another point, point B, where we have x2, y2. If we say a straight line passed through these 2 points, A and B, then based on the available coordinates, we can determine the gradient of that line. So it is on this, I want you to quickly work on this quiz from what we did last class. So here we have it. Find the gradient of a line joining the point M, which has this coordinate, and N, which has this coordinate. You can pause this video for a while you get it done. Alright, if you have been able to do that, it's expected that for us to get the gradients of this, gradient M is going to be y2 minus y1 over x2 minus x1, where this is our y2, this is our x2, this is our y1, this is our x1. So substituting those values, y2, which is 1 minus 3 divided by 5 minus 2. So we should have 1, this multiply each other, that's 4, 1 plus 3, that's 4, and divided by here, this is 3. Therefore, the gradient of the line joining M and N is 4 divided by 3. So if you get the same thing as this, definitely we're on the same track. So let's continue with today's content. Moving on, slope-intercept form. When we say slope-intercept form, that is the one that involves you are giving the gradient M, that's the slope, and you are also giving the intercept C. So equation of line from the slope-intercept form is expected to be y is equals to mx plus c. So basically here you have a gradient given to you and you have the intercept given to you. Just slot it into this form and you get the equation of that line. It's as simple as that. For the point slope form, we are talking about where you are giving the slope. Let's say you are giving slope m and you are also giving a point x, y. So if we are giving this, how How then do we determine the equation of line when we have this gradient and a point? When we have a gradient and a point, the equation of line is gotten by saying the gradient is given to you m equals the arbitrary y minus y1. So at that point, the point takes y1 and x1. We have y1 and x1. So divided by x minus x1. So when we have point and slope form, that is, you are given the slope and you are given the point in which the line is passing through, you can definitely determine the equation of the line by applying this information, that is, this formula. The third one, when you are given 2 points, say you are given point A and point B, say point A is x1, y1, and point B is x2, y2. How then can you determine the equation of line when you have 2 points? The equation of line for this is determined by saying the gradient, this part of the gradient, just say y minus y1 divided by x minus x2, x1, x minus x1 equals y1, y2, minus y1 divided by x2 minus x1. So when you use this, you're going to combine this, and that will help you to get the equation of line when you are given 2 points. And lastly, the general form of equation of line that can come in form of, you have, let's say, ax plus by plus c equals to 0, where a, b, and c are constants. That is, they can take any value. A, B are constants. And C, they are constant, they can take any value. So let's take note of it. When we have the slope and the intercept given to us, we make use of this. When we have the slope and a point given to us, we make use of this formula. When we have 2 points on the line given to us and we need to determine the equation of that line, we make use of this formula. And this is the last part, the general form, which whenever we are given it in this form, whenever we are given the equation of line in this form, it helps us to determine the gradient and as well as the intercept of that line. So let's take a look at some problems around that area to test our knowledge. Let's look at this. Find the equation of a line with slope 7 and intercept 2. Equation of line with slope 7 and intercept 2. From this question, you realize that one thing has been given to us here. Take note, the slope, the gradient, which is the same as slope, is 7, and the intercept, which is our c, is equals to 2. So now, think about it. You are given m and you are given c. We then need to bring back that knowledge of the equation that says y is equals to mx plus c. Just as simple as that. Then let's substitute the value of m and c into that general form to obtain the equation of this line that we have here. So we have y is equals to m here, that's 7 bracket x plus c, which is 2. Therefore, the equation of the line becomes 7x plus 2. 7x plus 2. So now, that is the equation of the line that has the properties given to us here. As we take it further, we'll learn more and we'll try out some of it with graph. So be sure that we are on the same line and we are doing the right thing. All right, let's move further. We have another question here. Find equation of the line passing through the point. We are given 1 point and having slope this. So let's first take notes. In this question, we are given that the slope, which is the gradient, the slope is m equals 3 divided by 4. That's 3 over 4. And the point given to us has the coordinate -8 and 3. Coordinate -8 and 3. Recall, whenever we have the gradients and the points, we use the formula m equals y minus y1 divided by x minus x1. Because we have been given the y1 and x1 here and the gradient, so we connect it with the arbitrary y and x that helps us to determine the equation of that line. All right, now this is our x1, this is our y1. Let's substitute it into this as well as the m. That will be 3 over 4 equals y minus y1, which is 3, divided by x minus x1. x1 is -8. So this will further reduce to 3 divided by 4 equals y minus 3 divided by 8, x plus 8, x plus 8. So when we get to this point, it's so easy. What we need to do is just to cross multiply. When we cross multiply, we obtain 3 open bracket x plus 8 equals 4 open bracket y minus 3. Isn't that interesting? All right, so we then do something. We open the bracket. That becomes 3x plus 3 multiplied by this. That gives us 24 equals, we do the same thing here, 4y minus 12. Now the next thing is, let's try to rearrange in which we have the terms with letters to one side and the terms without letter to the other side of the equal sign. So we have 3x, taking this to this side, becomes minus 4y equals minus 12. This is plus 24. Taking it to the right hand side, it becomes minus 24. Then we can further say 3x minus 4y equals minus 36. So we can say, therefore, the equation of the line passing through this point and having this slope is 3x minus 4y equals negative 36. That is the equation of that line. You find that interesting, right? So if so, I want you to quickly work on this exercise. Let's look at this exercise. What we have here, find the equation of the line passing through this point with a slope 4. You can pause this video and quickly go through it and see if it's something that we have in common or if you're getting the concept. So equation of the line passing through this point with this slope. All right, let's quickly look at it together. So from what we have here, passing through the point, we have the point 2, 5, and we have the slope, the gradient given to us as 4. So when we have points and gradient given to us, to obtain the equation of the line, we make use of the slope, that is, the gradient equals y minus y1 over x minus x1. Recall the gradient has been given as 4, so we can say 4 equals y minus the y1, which is this, 5. So we have it as minus 5, and x minus x1. The x1 that we have here is 2. We have it as 2. Now we've been able to do this. So if you cross multiply, this can be seen as 4 divided by 1. So cross multiply, we obtain 4 open bracket x minus 2, which is going to be equals to y minus 5. Interesting. Then we open the brackets. Opening the bracket, we have 4x minus 8 equals y minus 5. From here, we are close to having the equation of that line. What we just need to do is collect the like terms by saying that, pick all the terms that have letters to one side and the ones without letter, take them to the other side. So we have 4x. This one is positive y. Taking it to this side, it becomes negative y equals, this is negative 5. It remains at that right hand side. Then negative 8 from the left hand side to right hand side becomes positive 8. So we have it as 4x minus y equals, subtract this, that will give you 3. It just said fantastic. Yes. If you have done it this way, wow, you've done well. It's not out of place. It's also possible maybe you have gotten something like 4x minus 3 equals y. Yes, it's still the equation of this line that we are looking for that has these properties. Interesting. So we've learned when we are given the gradient and the intercept. We have also learned when we are given a point and the gradient. Let's now go to when we are given 2 points. When you are given 2 points on a line and you are asked to find the gradient of that line. So how do we go about that? That is what we are moving to. Take a look at this question. Find the equation of line passing through points A and B. So here 2 points are given to us, A and B, and we are to determine the equation of line passing through this point. Here we are given 2 points. So we have point A that has coordinates 1, 2, and we have point B that has coordinate 3, 6. Remember, when we are having 2 points and we are to determine the equation of line passing through that 2 points, we have y minus y1 divided by x minus x1 equals y2 minus y1 divided by x2 minus x1. Where at point A we can say we have x1, y1, and at point B we can say we have x2, y2. What we then need to do is to substitute all those coordinates into the formula. So this becomes y minus y2 here, y1, which is 2, divided by x minus x1, which is 1, equals y2, that's 6. 6 minus y1, which is 2, divided by x2, that's 3, minus x1, which is 1. Going for that, this becomes y minus 2 divided by x minus 1 equals, this then becomes 4. You are subtracting 2 from 6. Same way you are subtracting 1 from 3, gives you 2. So if we go further, we cross multiply. When we cross multiply, we will be left with 2 open bracket y minus 2 equals 4 open bracket x minus 1. And when we do this, we then have to open the bracket. It becomes 2y minus 4 equals 4x minus 4. If we do this now, we'll be left with 2y minus 4x equals minus 4, take this here, plus 4, and that will be 2y minus 4x equals 0. So this is an equation of line. You can also decide to express it as saying divide through by 2. If you divide through by 2, you will have y minus 2x equals to 0. This equation is still valid for this line given here, just as this is valid for this. So that is the equation of that line. Now let's try to put these 2 points A and B on the graph. Let's see what it will look like. Let's put it on the graph where we have point A says we have x is 1, y is 2. X is 1, y is 2. That's this point. And the other one say this is point A now. Point B says when x is 3, y is 6. When x is 3, y is 6. So let's plot it and look at the way it. Now we've been able to plot this graph. Let's now look at it. If we look at this graph carefully, where point A says x, y, which is 1, 2, and point B says this, right? If we look at this, it shows that if it's possible for us to project this downward, you realize that it's going to pass through origin, the point O. If that straight line is extended forward, it's going to pass through point O. That means bringing us back to the general formula that says y is equals to mx plus c, where c is the intercept on y-axis. So if you look at it, the intercept on y-axis is 0. So this is 0 plus. Now if you try to find the gradient of this line, look at it here, it's going to be like this. So from 2 to 6, difference of that's 6 minus 2, that's changing y-axis. For changing x-axis, we have it as 3 minus 1. So if we look at it, changing y-axis is 4. Changing x-axis is 2. When we do this, this will give us 2. So the gradient is 2, and that will be 2x is equals to y. You realize that this equation can also be moved to this one if you take this 2x to the right hand side. So it shows that in calculation and in practical, what we are doing is valid. What we are doing is valid, both in calculation and in practical of it. Isn't that interesting? So we've learned a lot in today's class, where we've learned how to determine the equation of a straight line when we are given the gradient and intercept, when we are given the gradient and the point, when we are given 2 points, and at the same time, the last explanation explained to us that if we are given any equation of line in the form y plus x equals to 0, one thing we should know that From given equation, you can determine the intercept and the gradient. Let's take, for example, if you are given equation of a line to be 2y plus 4x minus 6 equals to 0. If this is equation of a line and you are asked to determine the gradient and the intercept, it's one of the easiest things to do. What you need to do is that make y the subject of the formula from this. So it becomes 2y equals 6 minus 4x. Divide through by the coefficient of y here, which is 2. You have y is equals to this one that will be divided by 2, that's 3 minus 2x. So for this equation now, if you are given this equation, if you are asked to determine the gradient is the coefficient of x when you make y the subject of the formula. Take note, whenever you are given any equation of a straight line and you are asked that from the equation, you are to determine the gradient and the intercept. All you need to do is make y the subject of the formula in that equation. And when that is done, whatever is the coefficient of x is your gradient, and the other part that is standing alone is your intercept. So for this now, the gradient here, m is equals to, the gradient m in this one is equals to negative 2. That means the gradient of this equation, m is equals to negative 2. And the intercept, that is where this line will touch y-axis when plotted, the intercept c is equals to 3. So if you enjoyed today's class and you've learned something, I will leave you with this exercise to practice. You practice these two problems. Don't forget to subscribe to our channel, like for more interesting educational videos like this. So I'll be awaiting your response at the comment section below on the solution to these two problems. Till I come your way next time, I am Ademola Folari, your mathematics tutor.